Guys, you miss me? I miss you guys so much. I hope everybody's happy and healthy and doing everything they can to not go crazy during this quarantine. I know I'm starting to lose it a little bit myself. Um, I know I said I was just going to post notes on Google Classroom and some YouTube videos and have you guys, do the best that you can to figure it out. But I tried that last week with my geometry classes, and it just seemed like there was just so much confusion because you guys are so used to me teaching you, and there's nothing wrong with that. So I went out and I braved Walmart and this deadly virus because I care about you guys so much, and I got myself a nifty whiteboard. So I'm going to do the best I can to teach as if I was in the classroom, even though we're in my closet, and just give you that little sense of comfort. I hope it goes without saying that it is illegal to use this video for any other purposes than what it's intended for, is educating you guys without my permission. So please just do not do that. Not that I think any of you would. Just protecting myself. So I'm going to post all the notes from today's lesson and the next two lessons because I'm going to do this in 3 parts. So everything you need for this week, I'm going to break up into 3 videos. So no, I'm not wearing the same clothes for 3 weeks straight. I'm just breaking them into smaller portions. So I am going to post all the notes from each session after this. So I'd rather you just pay attention to the lesson rather than try to write notes as I'm speaking, because I know some of you would, some of you would not, but they will be posted for you after this. So I'm not going to sit there and write all of these steps out on this whiteboard because that would just take me forever. Instead, I'm going to do problems and talk the steps out with you guys. So I'm going to hope you can see this as best as possible. It's the best thing I could think of right now. If you guys have any other ideas, let me know. But other than that, I'm going to get started. Oh, my dog's trying. Come here. Say hi, Bee. Say hi to everybody. Hi, Bee. Oh, little dog. To make you happy, All right, so let's start super simple. You guys did solving square root functions earlier in the year where you took the square root of both sides in order to solve the problem. So now we're just going to make the radicals bigger, 4th root, 5th root, cube root. So to start really super simple, I'm going to take the cube root of x plus 1 equals 27. Right? So far, so good? All right, so before, when they were squared on both sides, you guys took the square root to get rid of the exponent. Now, I'm going to take my magic number, just like one for our house party, and I'm going to raise both sides, because what you do to one side, you have to do to both, by that magic number, which in this case is 3. Right? So that gets rid of this radical. And I'm left with x plus 1. Oh, that was a really big number. You know what? I'm going to change this. That's what happens when you wing it off the top of your head. I'm going to make. I'm not going to give you big numbers. And we get 8. Okay, so then I have x equals 7 because I subtract 1 on both sides. X equals 7. Good. All right, so it's going to get harder from there. That was just a basic function about like how would you solve the problem when you got down to the base of it. So now we're going to do a harder problem, and I'm going to walk you through all the steps. So that was our walk. Now we're going to get into like a speed walk. Okay. So real example 1. I have 2 square root of x plus 1 equals 4. Okay, now step 1, remember, you cannot take square roots or square or do any of that until the radical is isolated. You're solving for x, but you cannot raise the power until the radical is isolated to the best of your ability. So first, I need to divide both sides by 2. Right? Divide both sides by 2, and I get square root of x plus 1 equals 2. Okay, how do you get rid of square root? Wish there was people to answer me right now, but there's not, so I kind of feel crazy. To get rid of square root, I raise it to the 2nd power because there's that invisible little magic number 2 in front of square root. So that cancels that out. And I'm left with x plus 1 equals 4, right? Subtract 1, I get x equals 3. Now you always want to check your solutions because you can have extraneous solutions. Yes, that big word is back. You can have solutions that don't end up working in the end. So we look at 3. We have 3 plus 1 is 4. Square root of 4 is 2. 2 times 2 is 4. We are good. We checked. That was a good problem, but you will have extraneous solutions. Okay. All right. All right, example 2. Example 2, we have the cube root of 2x minus 9 minus 1 equals 2. Okay. And obviously we need to get rid of this minus 1 because then the radical will finally be by itself. So get rid of minus 1, you plus 1. And we have the cube root of 2x minus 9 equals 3. How do you get rid of cube root? You get rid of cube root by raising both sides to the third power, that magic number 3. And I have 2x minus 9 equals 27, right? 27, add 9 to both sides. And I get 2x equals 36, divide by 2, x equals 18. Okay, now we check our answer because we always check it every time. So 2 times 18 is 36. 36 minus 9 is 27. Cube root of 27 is 3. Minus 1 is 2. We are good. Okay. Sorry, I know I keep looking over. I keep checking my dogs because when they're quiet, I feel like they're bad. I really think this thing's gonna fall on me and I'm gonna like get crushed. The only one they had left in the store was glass. Yay. And it's on a construction sawhorse, so it's not that sturdy. All right. So those were the first type. Now I'm going to show you what it looks like with an actual extraneous solution, so you kind of know what I'm talking about when I'm saying that. So if I give you, this is definitely like a jog now, getting into a run. Like we're definitely jumping right into it. So I have x plus 1 equals the square root of 7x plus 15. Okay. Now the radical, even though this looks ugly, the radical is completely by itself. So you can go right into getting rid of the radical, meaning I am going to square both sides to get rid of that radical. For the love of God, do not distribute this exponent. I know I've told you guys that a million times in class, but please do not distribute this exponent. This means, yes, you're gonna have to FOIL. I can hear all the moans and groans all the way from in my closet right now from you guys at home. Yes, you will have to FOIL. This does get harder. Okay. So if we FOIL this out, we get x squared. And then I have x and x, right? X squared. And then I have x plus 2x plus 1 times 1 is 1. So I kind of did that all combined. This would have been x squared plus x plus 1. And I combine it all. Ugh. Now we have a quadratic. If we were in class, I would say, oh, what do you have to do when you have a quadratic? And you would all look at me with blank stares until that one person said, set it equal to 0. So we're going to jump right to that. Whenever you have a quadratic, you can only solve it by setting it equal to 0. So you're going to minus 7x and minus 15. And I know something already triggered in your brains when there's 3 make a t, and you're all moaning and groaning again. What multiplies to negative 14 and adds to negative 5? We have negative 7 and 2. Right? So I have x equals 7 and x equals negative 2. This is where the check comes into play. We have to check our solutions, especially when there's more than one. So we look at the 7, right? So 7 plus 1 is 8, right? 7 times 7 is 49, plus 15 is 64, square root of 64 is 8. So that is good. We like that one. Negative 2. Negative 2 plus 1 equals negative 1. Ooh, well, that's not good because right off the bat, you know you can't have negatives in even roots. Doesn't work. Can't have it. So that does not work. Okay, the square root of 1 doesn't just equal negative 1. You can't do that. So does not work. Hope that's not too bad. All right. So we're really about to go for a sprint. Don't worry, I'm not going to put a million of these on a test. You will have one of them on your homework because you do need to know how to do it, but this is definitely like the sprint. This is the hardest it's going to get. We have one more example after this that's going to kind of, be our cool down where we're going to go back down into like a jog, but this is definitely the hardest one, and I'm being honest with you. I picked like when my boyfriend was in the firehouse to do this because he would probably think I'm nuts in here talking to myself. So starting to think that anyway. All right, so here I have the square root of x plus 2 plus 1 equals the square root of 3 minus x. Yikes. Now, this whole time I've been preaching to you guys, just put my hair in the cap. The whole time I've been preaching to you guys is that you have to have the radical by itself in order to raise it to an exponent. Well, what do we do here? There's two radicals and I can't move that one anywhere. So when you get to this case, the only thing you can do is just go ahead and raise it to the power. Now this becomes ugly. This becomes really ugly because this is a bunch of, this side's pretty, but this becomes this twice. Yikes. So we will take this one step by step. We have the square root of x plus 2 times the square root of x plus 2 is the square root of x plus 2 squared, which cancels that squared and square root out. So we have x plus 2. Okay, that was that one. Now we have plus the square root of x plus 2 plus the square root of x plus 2 plus 1. Okay, I'm going to simplify this. There are two of these, right? So I have x plus 2, x plus 2, and then 2 plus 1 is 3. Okay. So now I'm back to, I have one radical. I need to get that radical by itself to cancel it out. So I'm pretty much doing this twice. When you have two radicals, you have to do the process twice that you would have done in the other problems. Yes, I know, not fun. I understand. So I have to minus the 3 and minus the x. So minus 3, that would cancel those out. Minus x would give me negative 2x, right? Negative x minus x is negative 2x. I'm going to divide both sides by 2. So I get the square root of x plus 2 equals negative 1. Okay. All right. Sorry, I just lost my train of thought. Oh my God, I'm losing my mind. I knew I lost my mind. See, it's just like we were back in class. I lost my mind. I didn't have anybody to tell me. Negative 2x divided by 2 is negative x. There we go. We're good. Quarantine brain. Right? All right, so now we're squaring both sides. I'm running out of room. And I'm going to write it over here. I have x plus 2 equals x squared, because that negative x squared would be positive x squared. Then you need to bring everything equal to 0. So I have x squared minus x minus 2 equals 0. When there's 3, you make a t. So I have what multiplies to negative 2 and adds to negative 1. That's negative 2 and 1. So negative 2 and 1. Right? And I'm just going to move this down for purposes for a second. So then I have x equals 2 and x equals negative 1. But I have to check my work. All right? So 2. If I plug this in, 2 plus 2 is 4. The square root of 4 is 2, plus 1 is 3. Right? And then if I plug 2 in here, I get 3 minus 2 is 1. The square root of 1 is 1. So 2 does not work. So that is bad. Don't like that one. Negative 1. Negative 1 plus 2 is 1. Square root of 1 is 1. 1 plus 1 is 2. 3 minus negative 1 is 4. Square root of 4 is 2. 2 and 2. Lovely. Negative 1 is our answer. So again, please don't freak out. That one's not easy. You're probably going to have to look at that a few times. You're probably going to have to rewind this video a few times. That one, if there's any, will only be one, I promise. Okay. So now it's time for the cool down. We're going to do one more easy problem, and then I promise that is the end of this lesson. Again, all of these notes are going to be posted, and I even did the check on the notes, so you can see what I'm doing for the check. They're a lot more detailed. This is just me kind of explaining to you what I'm doing in those notes in hopes to kind of answer your questions before you even have them. So example 4 is solving with rational exponents. It's the same thing except then you have exponents. It's really not that difficult, I promise. Not just like the last one. So I have 2x to the 3/4 plus 2 equals 10. Okay. All right, same thing. You cannot do anything with an exponent until it's by itself. So this minus or plus 2 has to go by minusing 2. Okay. All right, now since this is by itself, I can get rid of that exponent. How do I get rid of that exponent? I'm going to multiply by the reciprocal. I'm going to flip it because if I have 3/4 and 4/3, that's 12 over 12, which is 1. It ends up canceling it. So anytime you have a rational exponent, which just means a fraction exponent, you're going to flip it once isolated. So I'm going to multiply both sides by 4/3. Okay. Ooh, that's a little bit messy. Sorry. So I have 2x equals 8 to the 4/3. Okay. 8 to the 4/3 equals 16. And so x equals 8. Check your work. Once we check our work, 16 to the 3/4 is 8 plus 2 is 10. We're good to go. And again, guys, if you want the calculator that we use in class, I put a link on the stream over a week ago where you can download the exact math print calculator, the little one that we have in class, or the graphing. You can use either one. It's a free 6-month subscription from Texas Instruments, which is awesome. Okay. I'm going to do one more of those and then we're done. Okay, last one, just because I want to know that you guys really have this down. Okay. So this one's already isolated, which is really nice. So all I have to do is get rid of this 1/2. I know it's a little bit blurry. I'm sorry. Just get rid of that 1/2 by multiplying or raising the exponent by 2/1, which gives me x plus 30 equals x squared. And then that's really nice. You know when it's x squared, it has to be equal to 0. So I'm going to bring everything over. You can't get rid of that when there's 3 make the t, right? Well, multiplies the negative 30 and gets me -1, -6 and 5. So I have x equals 6 and x equals -5. I am going to check my solutions like always. So 36 to the 1/2 is 6. And then 6 and 6, that one's good. We like that. That's good. Okay, 30 minus 5 is 25. Square root of 25 is 5. Ooh, 5 and -5 are not the same thing. So our answer is only 6. So again, these notes are going to be on Google Classroom, guys. If you have questions, feel free to email me. If you email me from 8 to 4, you will get an immediate response back. Some of you have already seen that. After 4 to 9 o'clock at night, I might be eating and doing things, so it might take me a little longer, but I will answer you back. Okay? But I love when you put comments on the Google Classroom feed, because then all of you can see your comments and the answers that kind of help us all out. All right, so that was part 1. I'll see you again in part 2.